Vladimir Lovidor. These are my team members, Alberto Garcia and Daniel Alonzo, and we're Group 10, and this is our presentation, Unmanned Ground Vehicles. Our core objectives is to design a program for a robotic platform, mainly unmanned vehicles, parking spaces, and avoid collisions with other robotic platforms. Literature review. This is a background history. In 1992, Volkswagen was working on a self-parking assist option in its own vehicle called the Future Concept Car. It added approximately $3,000 onto the vehicle, but they decided not to, that the public wouldn't go for such an expensive item. But now, Toyota and its Toyota Prius and Lexus car models, they have introduced the self-parking. And in the Defense Advanced Research, aka DARPA, they have developed a new program called the Urban Challenge, where other universities such as MIT to develop unmanned ground vehicles and basically to perform these driving traffic, merging and negotiating intersections where they will allow cars to pass by, stop, or allow persons to cross the street without running them over, etc. And now, Alberto Garcia.
Alright, so the components of our project, we're going to use the BOBA sensors, infrared sensors, line sensors, resistors, and the battery. Alright, so our alternative design is working with just one BOBA that to autonomous vehicles in future market and self-parking device in today's market, using the Key2i line sensors and the ultrasound. But our final design was working with two bobots instead of one, autonomous vehicles in future market and the self-parking device in today's market, using the Key2i line sensor, the ultrasounds, the infrared sensors.
So here, this is the early stages of our project. Here we were basically setting up the two bobots, connecting all the circuits, making all the connections with the sensors. In the next list, this is the early stages of our model that we have here. Basically the two scenarios that we wanted to convey, cars driving down the street, checking for empty parking spaces on their right, and then perform the parallel park maneuver. If there are no empty spaces while they were driving on this side, go on the roundabout and continue checking for empty spaces on the left. This is a sample of the code that we used for our project. Again, early stages using soda cans as cars. Next. Alright, here we have a picture of the Boba driving down. One has already found a parking spot parked. The other one is continuously checking for an empty parking spot and eventually will park where it's supposed to. Here we see the simulation of where one Bobot crosses the intersection, and the other one also, if it detects something that's in the way, it will stop, so it will avoid a collision, wait for the car to pass, and then take its turn to cross the street. Here's little screenshots of the Bobot. The first Bobot, which was in front of the second one, has found the empty parking space. It's performing its parking maneuver. The one behind it decided to wait so it won't bump into it. Once the first Bobot has parked, the second one says, "There's nothing in my way, I can continue going forward." So it continues going forward and it detects the second empty parking space. Once it detects that, it begins to perform its parallel park maneuver and until they're both parked in the park position. Here we see the Bobot's eye view. As you can see in the center, here this infrared sensor is continuously checking if there are any objects in front, and on the far left you can see the other infrared sensor checking for empty parking spaces. Here's a video of the two GoBots in action. As you can see, until the second one started moving. So now they're both driving down the street looking for an empty parking space. The following video, we will see them in the intersection. These were the early stages where we were trying to fix our program and testing, calibration. So we see, after they cross the street, they park in the appropriate spaces.
Alright, so the improvements that we want to make to our design is adding sophisticated servers, multiple ping sonars, navigational GPS unit, color sensors, and the design of a bigger boba to more storage and sensors. Alright, so what we want to do if we have more time and more funds is to implement this into our world using not only the line sensors but also color sensors, and putting the colors, different lights on the streets. So when the sensor of the color sensors sees a different color, let's say that it senses the red color, it says that he has to park. He has to wait is the stop sign. If it is a white color, it means miles per hour zone. A black color means that it's 80 miles per hour speedway. That's what we're trying to do if we have more time and more money.
Alright, so here are some acknowledgements of people that helped us complete our project. We have Kelvin, which helped us a lot with the programming difficulties that we were having. Professor Tosinoglu, Mario Vargas, Luis Dayo, and Melissa Vittoria. Following our list of references, and that concludes our presentation.